Hey everyone, welcome back to my channel Learn with PR. I hope you all are doing great. If you want to master data structures from basics to advanced, this playlist is going to be super helpful for you. We have already completed a stack using array and linked list and its operations in details and started queue. So if you have not watched that playlist yet, go and check it out first. Link is in the description. And make sure you like the video, comment your doubt, share with your friends, and do not forget to subscribe to my channel that is Learn with PR. So far, we have completed queue implementation using array and linked list. And now it's time to check out algorithm and time complexity of it. Basically, a queue is a linear data structure where elements are inserted from one end and removed from another end. It follows the principle of FIFO, first in, first out, first come and first serve, you can say. So FIFO means the element which is inserted first will be removed first. All right. So now let's check out the algorithm of it. So here I have written an algorithm using array first. So NQ means insertion, DQ means deletion. All right. So element you have to check are inside queue or not. If it is full, all elements are full. If queue is full, that means what rare is equal to max minus 1, right? If true, then there is no space left to insert a new element. So overflow condition it will say. Okay. If the queue is empty, that means the condition is you have to check front is equal to minus 1. That means what? There is no element inserted yet. Okay. So if this is true, that means you have to set front as 0. Okay, suppose you have this array starts from 0. So front agar minus 1 hai, so there is no element. Okay, you have to set front as 0. So front is equal to front plus 1, you can do simple. Okay, and have to upload a value here. Okay, but you know very well we have to insert element from rear end. So there is a r as well. R is right now minus 1. You have to say r rear is equal to rear plus 1. Increase one time rear. So rear again becomes 0. So that means pointing to this location. So write down ARR rear. ARR rear means ARR 0 will get the value of value. Suppose 10. So you will upload 10. So that means how you can insert it. Okay, this is how we can insert. So when you are inserting, that means how much time you have taken. Big O one you can say. So in Enqueue function you will say a single element is inserted at the last position, which takes a single memory allocation operation which is done in a constant time. That means big O one. That's why the time complexity of it big O one. Okay. And if you want to if you want to check the space complexity, so no extra space you are using, so big O one will be the space complexity. Okay. So this is a simple how you can insert a new element. एक element को जब insert करते हो तो one by one ही तो insert करोगे ना. Okay, so basically you are inserting from the rear end only. So it rear end में 10 value आपने जब डाला तो कितना time लिया उसने? एक ही time constant तो लिया, constant time लिया ना. Okay, and if you are performing a same thing for the second element, okay 20. So ये तो आपने पहले कर दिया, तो इसके लिए फिर से कितनी हो जाएगी? Big O one. Okay, time complexity big O one होगी. Okay, all right, so this is how we can do. Okay, Enqueue insertion using array. Now let's talk about deletion. If you want to delete it, so we have to check if the stack is empty. Agar stack empty hai, so that means what? You can't delete any element. So what will the condition? Condition you will say front is equal to minus 1 or front greater ho gaya rear se. That means under flow condition there is nothing to delete. So there is nothing to delete. So you, if this condition is true, if the condition is false, then you have to access the front value क्योंकि front से ही delete होता है. So front हमारा क्या बना अभी? 20 sorry 10 है front हमारा. Okay, front is right now 10. Okay, I'm writing one more thing for you. Suppose this is an array having only one element. That means front भी इसी को point कर रहा है, rear भी इसको ही point कर रहा है. This is a one scenario. This is a second scenario. So अगर front हमें delete करना है, that means ARR front will remove 10 will remove from this. Okay, so just change front as front plus 1. Now front is pointing this location and rear is also pointing this location. That is okay. Right now 20 is, right now 10 deleted, 20 remain in the queue. This is a one scenario. Okay, अब मैंने कहा कि अगर मेरे पास सिर्फ एक ही वैल्यू है, अगर हमारे पास सिर्फ एक ही वैल्यू है तो मेरे को क्या करना है, फ्रंट विल गेट द वैल्यू ऑफ फ्रंट प्लस वन, फ्रंट नाउ पॉइंटिंग दिस लोकेशन, फ्रंट इज नो लॉन्गर दिस। ओके, डन। तो यहाँ पर क्या, रेयर तो इसी को पॉइंट कर रहा है ना, तो दिस कंडीशन इज बिकम ट्रू, यू नो। दिस, ये कंडीशन क्या है, फ्रंट इज ग्रेटर देन रेयर, सो रेयर इज जीरो, फ्रंट इज वन, वन, दिस इज अ वन इंडेक्स and this is a zero index. Okay, so this condition become true, that means again underflow condition. Okay, अगर आपके पास ऐसा होगा that means ये condition already फ्रंट ने डिलीट कर दी है, this is no longer now front but rear is pointing this zero location. Okay, so this condition will also say there is no element, so this is a DQ. Okay, so the time complexity, if you want to say in an array implementation, only an arithmetic operation is performed, that is front pointer, front is incremented by one, है ना, which is a constant time function. So big O one will be the time complexity for this deletion as well. Okay, and space complexity, no extra space is utilized for the deletion, है ना, deleting an element from the queue, that is big O one. Okay, this is what, this is a simple algorithm. And the time complexity, this is how you can do the time complexity big O1, both will get the value of big O1, time complexity will be this. Okay, now next, so here q, we are saying q using linked list. So insertion deletion same thing, first we have to create a new node, है ना, हमें new node create करने का है. So whatever the value, it will get the data and the next pointer will get the value of null. Okay, so in this linked list we have a dynamic memory allocation, so we don't need to take care of the number of elements, कितने डाल सकते हैं हम, कितने नहीं डाल सकते हैं, right? So we can give the allocation as well with the help of new keyword. Okay, now we have to check q is empty. अगर q empty है that means हमें front और rear दोनों को ही new node को assign करना पड़ेगा. So if rear is equal to null, that means provide this condition become true, that means what, front and rear both will get the value of new node. That means this is the only element, that is the first node you can say. Okay, पहला node है ये, तो front और rear दोनों उसी को point कर रहे हैं, right? But if it is not true, so if it is not true, that means else part will work. Okay, we have to say rear of next, जो rear of next है will get the value of new node. जो rear of next है, जो last node हमारे पास है, उसके उसके नेक्स्ट में हमको न्यू नोड का डेटा अपलोड कर देना है, मीन्स एड्रेस अपलोड कर देना है, और रेयर में भी हमें न्यू नोड का एड्रेस डाल देना है. क्यों? क्योंकि वही तो आपका लास्ट एलिमेंट बना, न्यू एलिमेंट जो है, न्यू नोड जो है, वही तो बना ना. Okay, so this is how we can do it. So now the time complexity for this as well, only a new node is created and the pointer of the last node is updated. So this include only memory allocation space, hence it can be said that insertion is done in a constant time, so big O1, and no extra space is used, so big O1 will be the time space complexity as well. All right, this is how we can do it. Now let's talk about DQ. So DQ means deletion. You want to delete it, so first check Q is empty or not. Q means front हमारा null है, that means what, underflow condition, you can't do it, you can't delete anything. But yes, if it is false, then you can delete it, just take the help of temporary pointer. Okay, temporary pointer में we are providing the value of head, whatever the head pointer containing. So first pointer को तो contain करेगा वो, सो फर्स्ट फ्रंट को ही फ्रंट ऑफ नेक्स्ट कर दो ना, जो पहला वाला नोड है उसका ही जो नेक्स्ट पॉइंटर में जो वैल्यू दे रखी है उसको फ्रंट में डाल दो, तो वो सेकंड को सेकंड वैल्यू को तो ही क्या कर रहा है, पॉइंट कर रहा है. सो फ्रंट विल गेट द वैल्यू ऑफ फ्रंट ऑफ नेक्स्ट. ओके, एंड यू हैव टू डू वन मोर थिंग, रेयर को आपको नल करने का पड़ेगा, जब अगर इफ द फ्रंट ऑफ नेक्स्ट इज नल, है ना, तो फ्रंट भी नल हो गया. ओके, सो अगर फ्रंट आपका नल है तो सेट ऑल्सो रेयर एज नल, सो देयर इज नो एलिमेंट, देयर इज दिस कंडीशन इज फॉर ओनली इफ यू हैव ओनली वन नोड. ये कंडीशन आपकी वन नोड के लिए है, अगर एक ही नोड है तो, नंबर ऑफ नोड्स है तो ये तो काम ही नहीं करेगा. ओके, अगर वन नोड, ओनली वन नोड इज देयर, ठीक है, एक ही नोड है, तब ये काम करेगा ये वाला कंडीशन, अदरवाइज यहीं पे वो स्टॉप करके और इसको बोलेगा डिलीट कर दो टेम्प को, ओल्ड वाला नोड को डिलीट कर दो. तो दिस हाउ वी कैन डू इट. ओके, द टाइम कॉम्प्लेक्सिटी, सो इन दिस ऑपरेशन ओनली अ मेमोरी एड्रेस एक्सिस्ट, है ना, सो दिस इज अ कांस्टेंट टाइम ऑपरेशन, so that means we go one time complexity. and no extra space is utilized to access the first value. So that become what? We go one time complexity. Okay, so this is a simple explanation of your algorithm and time complexity. Okay, so both implementation have time complexity as big O one, but array used fixed memory and linked list use dynamic memory allocation. Okay, so this is a simple one. So today we learned about the algorithm of queue, array versus linked list. Okay, step by step explanation I have told you already, time and space complexity. Okay, so if you found this helpful, like, share and subscribe to my channel. Next video we will learn about the most important topic, that is a circular queue. Okay, so till then keep learning, keep watching and keep practicing this data structure. Okay, with the help of practice only you will achieve all data structure and you will succeed in your future. Thank you so much and keep watching.